In this lesson, we learn about the color wheels, and before I go into it, you should know there's a lot of debate on color wheels themselves. I did a lot of research, and there are a couple different wheels artists choose to work with, and some would argue that color shouldn't even be put into a wheel, but rather a spectrum starting at red and ending at purple. And some even went further and said that there is no true color wheel, as any color theory is an idealized model of how colors mix with each other. This can be overwhelming and sometimes confusing. So for this color course, I've narrowed it down into these two wheels that you can choose to work with, and I'll explain both and why there are two. The biggest difference is the primary colors that each wheel works with. While the traditional color wheel works with the primaries of red, yellow, and blue, the modern color wheel works with the primaries of cyan, magenta, and yellow. There's a reason for this, and I will show you why this is so significant. So first, let's talk about the traditional color wheel and why there are problems with it when working digitally. While most of us are younger, we learned this color wheel and how primary colors of blue, red, and yellow mix together with paint to create the secondary and tertiary colors. As we talked about in the previous lessons, we are not working with pigments of paint, but rather with light in the color mode RGB, which remember stands for red, green, and blue. So then you might be wondering, well, why weren't we taught red, green, and blue as primaries? Well, for traditional painting, it's all about pigments mixing together, and yellow is impossible to mix traditionally with those primary colors. So instead, we have red, yellow, and blue. When working with paint, you can see how we create the secondary colors of orange, green, and purple when mixing these traditional primaries. But this doesn't translate into digital, and I'll show you why. So here you can see we have the primaries of the colors we just painted and how it created the secondary colors of orange, purple, and green. So you would think that that would translate into digital, right? Well, unfortunately that's not the case, and we can test it here. So when we mix red and blue, let me make sure I'm on the right layer. When we mix red and blue together, we do in fact get more of a purple result from those two colors mixing, and you can see that on our color picker. Now, the problem is when we try to create green when mixing yellow and blue, as we can see here, this is the first problem when dealing with the traditional color wheel in a digital format, because no matter how much we mix blue and yellow, instead of creating green, we reach more of a dull, almost gray representation of green, as you can see here. And remember that this goes back into the idea that in a digital format, the colors are produced from light, not from pigments. So then you have to manually add in this green to complete the color wheel, and then you would take the other secondaries of orange and purple to create the tertiary colors when you mix one secondary with one primary, as seen on this lower graph here. So as I said earlier, there are two problems with the traditional color wheel. The first is not being able to mix properly. The second problem with this wheel is how it treats complementary colors. So while they are meant to be on the opposite sides of a color wheel and give the greatest contrast when placed next to each other, the traditional color wheel colors do not mix well together. When they do mix together, it results in a muddy color, often perceived as brown. And when we talk about this in the modern color wheel, you will see how that problem is also fixed. So now, let's talk about our second color wheel, which I have been calling the modern color wheel. The idea behind this wheel stems from working with complementaries that cancel each other out accurately, resulting in a neutral gray. So you can see how rather than red and green being opposite, on this wheel, red and cyan are opposite, and when mixed together will result in a neutral gray. This is from mathematically mixing colors to create a wheel based on the primaries of cyan, magenta, and yellow. Does this maybe sound familiar? Well, in the previous lessons, we learned about RGB and CMYK when working with light and ink. When looking at this wheel, you may notice that if cyan, magenta, and yellow are the primaries, then it should mix to create red, green, and blue as the secondaries. It can take some time getting over the idea that the traditional color wheel isn't the accurate wheel to work with. But when working with paint, many artists still use the traditional wheel. Now, if you're working digitally, with ink, or with the intention to print, I would definitely recommend becoming more comfortable using the modern color wheel. I wanted to test mixing these primary inks to create the secondary colors, so I went out and bought cyan, magenta, and yellow ink and mixed them together to see what would happen. The results were just as the wheel predicted. Yellow mixed with magenta to create red, blue mixed with yellow to create green, and magenta mixed with blue to create violet. The test worked with ink, so now let's test it digitally. So here I have the primaries of yellow, cyan, and magenta. And if I mix them traditionally, the same we did on the traditional color wheel, you can see how the in-between colors aren't quite as pure as the color wheel itself. And if I put them on the wheel, it would result in a more pastel-y looking wheel, which we know is not accurate. So after doing some research, I found out it was because ink and colors on the monitor don't mix together the same way pigments would. Instead, the modern color wheel primaries would multiply into each other, and we have a blend mode to help recreate that. So just like before, we have the primaries of yellow, cyan, and magenta. But this time, when I overlay them, rather than setting the layer mode to normal, I'm going to change it to color burn. And you can see immediately how now the secondary colors of red, green, and blue become present. And that is how we would create the accurate modern color wheel. So let me hide a few of these layers so we can see the modern primaries and the modern secondaries. And then from here, we would go ahead and mix a primary with a secondary color to create our tertiary colors. Now the last thing I want to show you is how the modern color wheel treats complementary colors. Because on the traditional color wheel, they would mix into a murky brown. But according to the modern color wheel theory, they should mix into a neutral gray. So on our chart, I'm going to choose a red and cyan, and in the theory, they should mix and meet in the midpoint at a neutral gray. So here I'm going to grab red, place it on the bar, and when I add the cyan, and if I keep mixing them together, you'll see the mix in between the two is in fact a very neutral pure gray. Now it may take some time getting used to how to mix them accurately because sometimes it'll be a little closer to red, sometimes it'll be a little closer to cyan. And this rings true with all the other complementary colors. So if you mix magenta and green or yellow and blue, they also would in fact turn gray when you mix them properly. And my advice and recommendation would be to test these experiments for yourself, because the more you become familiar with working in color, the more comfortable you will be when you're applying color to your own pieces.